Hello everyone, this is Mr. Slomkin. I wanted to talk to you about section 10.5, but this is going to be the second part, which is going to occur after section 10.6. So in 10.5, what we had learned about was some combinations and permutations, and there's a lot of different things that you can do with combinations and permutations. The main things are the ones we already covered, which is to calculate the number of outcomes or to calculate probabilities, but there are other things as well. And so this lesson is going to be different. It is not a statistics lesson or a probability lesson anymore. We're not calculating outcomes. What we're going to do is we're going to do something called binomial theorem. And we'll continue to use combinations. And so you're going to want to still know where that combination button is on your calculator. But we're going to do something very different with them. So let's take a look at some of these review examples up here at the top of the page. If you take a look, there's no story. There's no socks in a drawer or marbles in a jar. There's no cards, there's no dice. These are just basic raw algebra problems, and the directions say that what they want you to use is the distributive property to expand each of the following. So if you're going to use the distributive property, what you're going to want to do is you're going to want to take your 2 minus 3a and you want to square it. Now the way that you do that is you're going to take your 2 minus 3a and you're going to write it twice because it was a power of 2. And now that you've written it twice, now what we're going to do is we're going to use the distributive property. 2 times 2 is 4. And 2 times negative 3a is going to be negative 6a. Negative 3a times 2 is negative 6a, and negative 3 times negative 3 is going to be positive 9a squared. Okay, so once again, the direction said that they wanted us to expand, and this problem has definitely gotten longer. We can make it look a little bit better by combining our two a terms together. And we get this. There you go. Definitely bigger than the original version of the problem. Now the thing though is, what happens when the power goes up? So you got a power of 2, and this is a very simple, very basic Algebra 1 question, which you've done probably a million times. What I have over here is I have now a power of 3. So if you look carefully, what you'll notice is I've written out my x plus 4 3 times, and I need to use my distributive property again. Now when you're using the distributive property, it only really works for 2 at a time. So I am going to multiply these two, and I'm going to kind of ignore him for a little bit, and then I'll come back. So what we're going to end up with here is x squared and 4x and another 4x, and then we'll have a 16 at the back. Then I'll still have my x plus 4 back here that I haven't done anything with. I can combine these two x terms together, and so I will. That's going to give me x squared plus 8x plus 16, so that looks a little bit better. And now what I'm going to do is I've now shrunken this from having 3 sets of parentheses down to only having 2. And so what I want to do now is I want to multiply these 2 sets as well. So if I do that, what you're going to end up with is x cubed, 12x squared, 48x, and 64. Now, I'll be honest with you, I went a little quick on that, and I'm sorry about that. But here's the main thing that I want you to get out of this. It's taking longer. So this one is pretty quick. This one is certainly longer. We did basically the same amount of work we did for the first one, and then we did another round of work right here. So it's taking longer. Now let's go on to our third and final one right here. This is 8 plus 7x to the power of 18. Now the first step that I would need to do is I would need to write this 8 plus 7x 18 times in a row, and then I would need to start multiplying them together. Now honestly, that would take way too long. There's no way that I'm going to be able to do that. It is just too much. I would get confused, I would make mistakes, and it's just not going to work out well for me. So I don't think I can do it that way. It would require pages and pages. So what I would love is I would love a better technique. And the better technique to deal with a problem like this that is so big is something called the binomial theorem. So now, if you want to know what the binomial theorem is, here's the definition. Binomial theorem means that you can expand a 2-term binomial expression, which is exactly what we had up here at the top. Each of them only had 2 terms. But what's going to happen is you're going to do it without the distributive property or without FOIL. This is going to make the problems a little bit faster, so it should be faster. Most of the time, though, I'm not going to give you such a gigantic problem like this guy right here. So the work that we're going to do is still going to be considered to be a bit long and lengthy. So it does say kind of fast, but not really. So we will still be doing some pretty long work because these are big problems. I'm going to give you some big, complicated problems. We did all the easy ones back when you were in Algebra 1. Now I want to do some of the tougher ones like we have right here. But I want to do them in a different way. So let's take a look. here is the box that contains our binomial theorem. If you have something that only has two terms and a power, and you want to expand it, you can, but you need to expand it out using this pattern right here. Now, it looks huge and terrible and complicated, and I know that is something that makes a lot of people feel uncomfortable, but I'm going to try to walk you through it one piece at a time. To begin with, what I want you to notice is that it starts off with a big capital letter C. Those are for combinations. Those are the combinations that we've been looking at in the last couple sections. So each term is going to have its own combination, so we're going to start with those. Very simple, very easy to do. Then, the two terms that are inside of our parentheses, or our two binomial terms right here, are the A and the B. Each term gets an A and a B. So this is a nice, clear pattern. Each term gets a combination, each term gets an A, and each term gets a B. Now, also, the A's and the B's are going to get powers. And so I've got some rules right here for how those powers are going to work out. And so those rules are very clearly stated. I also have it set up in a little bit of a different way right here so you can see it a little bit more carefully. You're going to have your combination, and then you're going to have your first term. And those powers are going to start off high, and then they're going to decrease. You're going to have your second term, and those powers are going to start off low, and they're going to increase. So that is going to be the technique that we're going to use. Also, I want you to notice that something that's going to be particularly important in this section is going to be the number 0. We're going to use a lot of zeros. You can even spot them here. You can see zeros showing up all over the place. They're part of the combinations. They're part of the powers. They're everywhere. So we're going to use a lot of zeros. Okay, let's try one out. So this one's going to be a very simple one right here. It is asking us to expand x plus 4 to the power of 3. Now, we actually already did this problem up at the top of the page, and we have a good answer for it, but I want you to try to do it using the binomial theorem, which is specifically stated in the directions right here. So let's get started. So to begin with, what I like to do is, I like to do this in kind of like a assembly line fashion, and that allows me to kind of let my pencil just flow over the page and let my brain kind of turn off a little bit. And this isn't the only way that you do it, and if you want to look up other YouTube videos, I'm sure that they have other techniques, but this is the way that I think is the best. Because it is the easiest and it's the most straightforward. It relies the most heavily on the pattern. So as long as you know the pattern, which is what I've got for you right up here and up here, then you should be able to work your way through it very quickly and easily without having to fall into any kind of traps or confusion. So let's try it. Okay, so now what I'm going to do right here is I'm going to start out with my combinations, and I need a couple of them. And what I want to do here is the combinations are all going to start off with this power value, which is going to be power of 3. That is going to be our largest number, and so that's the number that goes in front. You always want your biggest number in front. Okay, now in the back number. If you take a look at our rule right up here, what I have is I have increase from 0. So the back number for each of these combinations, we're going to start off very small with 0, and then we're going to increase slowly. And when we get to our last term, something I'd like you to notice is that you are going to have this double. You're going to have it be the same number in the front as it is in the back. And that's how you know that you've written enough of them down. So it's going to start here at 0, and it's going to go until you hit the double. That is going to be, in this case, 4 capital letter C's. Even though it's a power of 3, I used 4 capital letter C's because, once again, 0 is important. Okay, now let's move on to our terms. So the next thing I want to look at is the x. And so the way that I'm going to work this is I'm going to give an x to every one of the capital letter C's that I've created. Once again, I'm kind of turning my brain off, and I'm just writing things down. Now, each x gets a power as well, and the rule for that power is going to be right here. It says decrease to 0. So in this case, we want to start off with our highest power, which is, once again, 3. 3 is our big number. And then we're going to decrease our way down until we reach a power of 0. Great. All right, last piece. Our last piece is going to be the 4. So now we want to, once again, give the 4 to every one of these terms. So each of them gets a 4. And each 4 gets a power. So now the rule for the powers for your second term is right here, increase from 0. Again, that's the same thing that we did with our combination right over here. So that means we're going to start off with a 0, and then we're going to increase to a 1, a 2, and then a 3. Something I'd like you to notice about all the powers that you've created, if you're looking at the combinations of the x powers and the 4 powers, you'll notice that each combination adds up to 3. That's on purpose. The original power was 3. All of your powers need to add up to 3 as well. So we've got that going on. Okay, lastly, right down here, it says always use plus signs. So in between each of these little clusters that I've built, I'm going to put a plus sign in between them. Great. Okay, so now what you need to do is you're going to simplify a little bit. So each combination is something you can type into your calculator, and each power that is attached to this 4 is something you can type into your calculator as well. So let's do that. 3 choose 0, if I type that into my calculator, is a 1. Now x cubed is not something I can type into my calculator, so I'm going to leave that as x cubed. Now 4 to the 0, I can type that one into my calculator. When you type 4 to the power of 0, you get an interesting answer, which happens to be 1. Okay, let's do another set. 3 choose 1. I can type that into my calculator, and I get 3. X squared, I cannot type into my calculator, so I will leave it alone. And then lastly, 4 to the first power. You probably don't need to type that one into your calculator because you probably know it. It's just 4. We've got 2 more to do. 3 choose 2. I'm going to type that into my calculator, and I get a very similar answer of 3. X to the first power is going to stay the same, but if you want, you can simplify it slightly. X to the first power is the same as x, so you can write it as x. And 4 squared. 4 squared is one of our first larger numbers that we're going to get. 4 squared is 16, so we're going to have that 16 there. All right, now our very last term. For our very last term, what we have is we have 3 choose 3. That is actually going to be 1. X to the power of 0. X to the power of 0 is going to behave just the same way that 4 to the power of 0 was, which was a 1. So it actually stops being a variable and it starts being a very nice 1. So we've got that right there. And then our very last piece right here, this is our largest number that we're going to get. 4 to the power of 3 is actually going to be 64. So we're going to get a 64 at the back there. Okay, so now this is our second line of work that we have. Our third line is going to be where our final answer is going to live. What we did is we set it up, and then we simplify, and now we're just going to make it perfect. So let's talk about this first term. At the front, we have a number 1, and at the back, you have another number, and even though there's an x in the middle, you can multiply the 1 from the front with the 1 from the back. It's not a very exciting piece of multiplication, you just get 1. And because it's not very exciting, you actually don't even need to write it down. You can write it as just x cubed. If you want to write it as 1x cubed, feel free. Same thing for our second term. We have a 3 in the front, and we also have a 4 in the back. And even though those numbers have an x in between, you can multiply. 3 times 4 is 12. And then you have an x squared right there. Let's keep going. So our next one is going to be this 3 and 16 combo. So you do want to multiply those together, and you're going to get 48. And then once again, you've got that x right there, and we don't want to forget about him, so we're just going to tag him on. And the very last term, which is one that I kind of crammed in right here, 1 times 1 times 64. There are no more variables there because we did have x to the power of 0, which wasn't very exciting. And that is going to mean that we're just going to get a number, and that number is 64. Take a look at the answer that we have written right here. That was x cubed, 12x squared, 48x, and 64. That is the exact same answer that we got when we did it up here using the distributive property. X cubed, 12x squared, 48x, and 64. So you can get it either way. So the question is, which way did you like better, or which way was faster? Did you find this way to be faster? Is that because I cheated at the end and I didn't show my last work step? Or did you like this way and you thought that this was faster? Because you can basically turn your brain off and just do a little bit of counting. You have to count down from 3 down to 0, and you have to count up from 0 up to 3, but other than that, everything else is just going to be done in your calculator. I don't know which way is the fastest way, which way you like the most, but I do know that you're going to need to make sure you're good at both of them. Okay, so this is a very nice, simple problem. Let's see if we can try one that's a little bit tougher. So at the top of the second page right here, what we have is we have another problem, and this one's tougher for 2 reasons. So one of the reasons that it's tougher is because it has 2 variables. It has m and it has n, and so that's going to make it tougher. The second thing that's going to make it tougher is actually very small and subtle. You might think, oh, it's because the power is bigger. No, I don't really think it's tougher because the power is bigger. The reason I think it's tougher is because it has a minus sign in it. And that minus sign right there is going to cause a little bit of trickery. So you have to watch out for it. I'm going to show you the shortcut for this minus sign at the end of the problem. I want you to make sure that you can work through it even if you forget the shortcut, though. So here is the thing that I'm going to do with my minus sign right off the bat. When I'm dealing with these problems, as I showed you on the front side, I'd prefer it if you always try to use plus signs whenever you can. And so in order to use plus signs as often as possible, what we're going to do is we're going to take this m minus n and we're going to rewrite it as m plus. And the thing that you would want to add here would be a negative 1n. And so I've changed the way that I'm thinking about the problem a little bit so I can deal with it a little bit more carefully. All right, let's get started. So to begin with, I'm going to give a combination or a capital letter C to each of my terms, and they're all going to start off with that high power of 4. 4 is going to be our big number. Now, for the second number, this is where things are going to start to count up. It's like riding a roller coaster. You're going to click, click, click your way up that very first hill. And you'll know you got to the top of the hill when you see the double, 4 and 4. There are 5 capital letter C's here, even though the power is only a 4. Okay, so now my first term that we have inside my parentheses is not just 2 or m, but 2m. So I'm going to give a 2m to each of my capital letter C's. I want you to notice that I'm writing them in parentheses. I think that's important, and I would love it if you did the same. I'll show you why in a couple of seconds. Now for my powers on my 2m's, this is where the roller coaster starts to go downhill, when you throw your hands up and you start to scream. So we just counted our way up to 4. Now what we're going to do is we're going to start at our power of 4, and we're going to count our way down to 0. All right, so the last term is now a little bit more complicated. It may have originally looked like it was just n, but now we see it is actually negative 1n. I'm going to give one of those to each of my terms that I have as well. And once again, I'm putting them all in parentheses. And I'm going to show you exactly why I'm putting them in parentheses in a couple of minutes. Now that I have them all written in, I want to use my powers. And once again, after you've ridden the roller coaster to the top of the hill and then ridden it back down, it's time to ride up another hill. So we're going to start off at 0, very down low, and then we're going to increase to 1 and 2 and 3 and 4. Please remember that your highest power is always 4, and you can't go past 4. So 4 is going to be our big number. 0 is always our little number. All right, next. Our very last step here is to use plus signs, as I'd stated. So we've already incorporated our negative sign into the problem, so we can use plus signs right here. Okay, so now let's see if we can take care of a couple of things. So what I'm going to do now is I'm going to go through and I'm going to simplify as much as I can. So 4 choose 0 is really great, and it just turns out to be 1, so that's excellent. Now, 2m to the power of 4. This is the reason why I wanted you to have parentheses on this. The reason why is because this power of 4 is going to be affecting the 2, and it's going to be affecting the m at the same time. So 2 to the 4th power is going to give us 16, and m to the 4th power is m to the 4th power. That one's not really all that exciting. Next, let's do the other one. So our other one right here is a power of 0, and that one is going to be affecting both of the terms as well. But the interesting thing about 0 is, though, it always produces the same result. Whether it be a number or a letter, you're going to get a 1. So there's not really all that exciting. You're just going to have another 1 right there. Great. Okay, let's move on. 4 choose 1. 4 choose 1 is going to be 4. All right, now let's do our 2m. 2m is going to get a couple of powers of 3. 2 to the 3rd power is actually 8. And m to the 3rd power is m to the 3rd power. Let's do negative 1. Negative 1 is going to get a power of 1, which means it's still going to be negative 1. And n is going to get a power of 1, which means it's still going to just be n. Okay, this is the one that gets really interesting, so make sure that you're paying close attention and that you're looking at your screen right now. So what we're going to do now is we're going to do 4 choose 2, which is going to be 6. That part's not the interesting part. We're also going to do our 2m, and that's going to get a power of 2 for everything. 2 squared is 4, and m squared is m squared. And now for the exciting part right here. Negative 1n squared. Okay, so now here's what's going to happen right here. Our negative 1 is going to get a power of 2. So let's talk about that for a second. When we had our negative 1n and we raised it to the power of 1, the negative 1 got a power of 1 and nothing really happened. The n got a power of 1 and nothing really happened. When we take our same negative 1n and we raise it to a power of 2, what's going to happen is that they each get their own power of 2. Now watch this. Negative 1 squared is actually negative 1 times another negative 1 right there. Now I know that you know this, but it can be hard to see unless you expand it like I have right here. What's a negative times another negative? And the answer is positive 1. So you actually, when you use this power of 2, you lose your negative sign. That's a very interesting thing. And so it does become regular 1 right there. The n also gets squared and it becomes n squared. So that one's going to be not very exciting. All right, now let's continue on. 4 choose 3 is going to be 4 again. 2 to the 1st and m to the 1st is 2m. All right, now negative 1 cubed this time. So now negative 1 cubed is interesting again. Let's take a look at that one. Negative 1 cubed is right here. Then negative 1 gets the power of 3 and the n gets the power of 3. Negative 1 cubed means negative 1 times another negative 1 times a third negative 1. Now, a negative times a negative gives you a positive right here, but then you're going to take that positive and multiply it by another negative. So you do keep your negative this time. Last time it disappeared. This time we keep it. That's interesting. And our last kit's going to follow in the same kind of pattern. So now 4 choose 4 is 1. 2 to the power of 0 and m to the power of 0 is also 1. Negative 1 to the power of 4. Negative 1 to the power of 4 means you're going to have 4 negative 1s. Each set is going to be a negative times a negative makes a positive. You lose your negatives right away, and they don't come back. So we are going to end up with a positive 1 right there, not a negative 1. We lose our negativeness this time. Okay, now we have got our second step. We've got our setup step, and then our work step. Our final is our third step, and that is going to be our final answer. So let's go through these one at a time. All of these things right here that I have collected from my first term, you want to extract all of the number parts, and you're going to multiply. So there's 3 numbers here. There's a 1, a 16, and another 1. So you're going to multiply all of those together. You also have your variables, and they're going to get tagged on at the end. You don't have to do very much thinking about those ones. Next, let's do these ones. So now, once again, we want to collect all of our number parts. So that's a 4 and an 8, but it's also this negative 1. 4 times 8 is 32, but if you multiply it by a negative 1, you get negative 32 right here. Watch that. Take a look at that. We just lost our positive sign, and we replaced it with a negative sign. We are going to keep our m cubed here as well, and we're going to keep our n. Let's do another one. Now we're going to take our 6 and our 4, and this time a positive 1. 6 times 4 is 24, and times a positive 1 is going to make it positive still. We're going to keep our m squared and our n squared. Next one, we're going to extract all the number parts. So that's 4 and 2, but also negative 1. 4 times 2 is 8, and times negative 1 means we're down to negative 8. Then we're going to have our m, and we're going to have our n cubed. And then lastly, our final term that we have is right here. We're going to extract all the numbers that we have, and there's a 1, and another 1, and there's no negatives. So we're going to keep it positive 1. And then you're going to have your n to the 4th. There's no m term for this last one. Okay, let me point out a couple of pro tips for you. So now let's talk about what actually ended up happening with the signs. So we started off with a negative in our original problem right here, and if you look at your bottom row, what you're going to notice is that there's a pattern for your signs. Our first one is positive, and then negative, and then positive, and then negative, and then positive again. So my idea for you was to rethink the problem as a +1 so it was as consistent as possible with the front page. The other way you can deal with this is you can ignore all the plus and minus signs until the very last end, and then you're going to follow this exact pattern each time. Positive, negative, positive, negative, positive, negative, positive, negative. So that works out well. Second pro tip that I'd like to point out to you. These problems are a little bit lengthy. They're always 3 steps long, which means they're consistent, but they are a little long, 3 steps. Something that is nice to do is have a quick little check. A check that you can do is just check your powers to make sure that they're all going to be consistent. You want all the powers to be reflecting this 4 right here. So the first one right here is a 4, very clear. Second set is going to be a 3 and a 1, and 3 and 1 add up to 4. Then we have 2 and 2, which are also going to add up to 4. We have 1 and 3, which are going to add up to 4, and then this guy is already a 4. So this right there is your final answer. I don't think I would want to FOIL this one. I think it would take too long to do 2m minus n to the power of 4th, and so I wouldn't prefer it. Even though this technique that I have right here is a little long, it is very clear and easy, and you can turn your brain off. The more you practice this, the better you'll get, and it'll become almost automatic. Okay, down here at the bottom of the page, what I have for you is I have 2 You Try It problems, and I'd like for you to pause the video right now and try those out. I'm going to put the answers for these You Try It problems on the screen in a couple of seconds. All right, here are the answers for your 2 You Try It problems. Something to note on this bottom one right down here is I want you to note that when you originally get the answer, you get your number terms in front and your S terms in the back, which is not exactly excellent. It's not terrible, but it's just not great. So the best answer would be when you switch it, and you would put your S terms at the front, and then the powers would count down until you got to no S's at all and your large 1,296 at the very back. Okay, please try out the Binomial Theorem 10.5 Part 2 worksheet now, and then catch up with me on Zoom if you have any questions at all. Thank you so much.